Students, welcome back to the part 2 of the lecture number 15. So, we started talking about how to use machine learning, right? What is machine learning? But at the beginning, let us clear about some of the concepts, and I showed you why machine learning is going to be important to design, discover, new materials, processes, everything, right? And this particular aspect was discussed in this paper called Informat. If you want, you can go details of that. So, we have to accelerate the material development time, rather we have to speed up, because we need a lot of new materials, and that is why machine learning is required. So, to be specific, how do you define a machine learning, right? What is a machine learning? Well, I have given one statement, that is a process by which machine automatically learn from the existing data. Is it so? This is a statistical method. It enables us or enables computer to learn from data without explicitly programmed to do so. Let us talk little bit more detailed manner. So, I will say ML, if I have to write ML, this is what? This is a computer program, right? This is nothing but a computer program, but what kind of computer program is this? Well, it is said to learn from experience. Let us call experience as E. It is said to learn from experience, but what kind of experience is that, right? So, that is very important. Experience with respect to certain task. And we define task by capital T. So, it is said to learn from experience with respect to certain task. Only task? Well, not. Something more. Certain task and performance. And let us talk performance as a capital P. Am I clear? So, that is what it is. It is a computer program. It is said to learn from experience with respect to certain task and experience. But what does it do? Okay. If it is called a machine learning, if the performance for the task, if the P for the task improves with experience, that is the key state line. So, it is a computer program which learns from experience with respect to certain tasks and performance. This is what is given to the computer program. And then what does it do? If the performance for the certain task improves with experience, then only it is called machine learning. Remember, when you start as a child, you simply cannot walk at the beginning, right? Slowly you started holding chair, table, everything, standing up. Then you learn how to walk, and that is what is the task. Task is the walk, right? Able to walk, and your performance will be decided by how many times you fall during walk. At the beginning, as a child, you will fall many times on the floor. Okay, sometimes you may damage your leg also if you are not careful. So, therefore, task is to get up and walk. Performance is decided by how many times you are failing. Now, as the time goes on, as the time will go on, what will happen? Your ability to walk will improve, or rather your performance for the walk will improve. You will fall less. So, machine learning is exactly like that. Machine learning starts with from experience, learn from experience for certain tasks with performance, and then it improves on. That is what is called a machine learning. Please remember this statement. This is very important, because there are many definitions of machine learning in the books, but they may not be correct. So, this then what has happened? Now, what is experience? Experience come from data. Experience originate from data, right? That is what is the experience is for the machine learning. You have certain set of data, you provide to the machine or computer, from that data it get the experience. Remember these aspects. Now, then once it comes to data, all of you we are living in the world of big data, right? Big data means a lot of data, okay, and this is what is used by all these big computer companies, Amazon, everything, how to sell product. Okay, they collect the data, and based on the data they design a product and sell that. What kind of shoes you like, what kind of shirts you like, what kind of hair dye you like, they will get from the survey, and based on the survey they will produce similar kind of shoes, similar kind of shirts, similar kinds of hair dyes for sell, and they know that if we get the prior experience, prior data, I can sell it much larger amount. Okay. Now, this data can also come from what? Come from imaging in material science. This can also come from spectroscopy. We measure composition of material by using spectroscopy. This can come from spectroscopy. This can also come from scattering experiment like X-ray diffraction, neutron diffraction, synchronous diffraction, all kinds of diffractions, and many more. You can measure mechanical properties, physical properties, or electrical properties, many things else. So that is your data. Okay, data is omnipresent. You cannot actually do not need to worry about the data, because for the last so many years, 200 years of scientific research has generated a lot of data. So, and you can also have theoretical data, right? This is experimental data, theoretical data from theory like density functional theory, or molecular dynamics, or molecular Monte Carlo, all kinds of calculation, theoretical calculation can give you data. So this is basically coming from computation. Computational approaches can give you lot of data, right? So your data is not a problem. From data one can get experience, and from experience one can get performance, right? So machine learning is supposed to improve the performance for a particular task with experience. Remember that. From data you can learn, but you can do also many other things like high throughput screening. High throughput screening is very important, because that is how you can screen out many many things which are not required. High throughput screening, or you can also have autonomous workflows. Data can allow you to do that. Autonomous workflow. Many times we decide workflow, right? When you are doing some experiments, when you are doing some work, we ourselves decide workflow. This is not autonomous, but here the data will allow us to do autonomous data workflow. So these are the two important aspects this data can actually allow. That is something which you have to remember, that data is our prime important thing. Data provides experience, experience provides you the performance or improvement of the performance. Okay. And in material science we are interested what? We are interested in many things. We are interested in design of materials, we are interested in discovery of new materials, we are interested in design of processes, many things. So material science, material research or material research basically revolves around what? Revolves around discovery of new materials, design of materials, and also synthesis of material. Sometimes you need to discover new synthesis techniques or new processing routes, that is what we call processing routes. And also optimization. If you are not going for optimization, it will be never ending process, and it may take you more than what you think about it. So these are the four important aspects There are many others, but I am talking about 4 important aspects: discovery of material, new material, design of material, synthesis of materials, and optimization. Optimization of any of these 3 is what is we do normally in material research. So, how do you incorporate machine learning into material research? That is something we need to understand. And now let us talk about design, right. What do you think we do design? How do you design materials? Let us talk about it. Discovery is something which is probably much very few people can do, but design is something which everybody can do. So, what is the design? Well, design means you have certain target properties, your employer asks you to design a new material with that target properties, right, that is what it is. So, how do you do that? Well, there are 2 design approaches. One is called the indirect design, direct design approach, other one is called inverse design approach. Okay. So, let me just remove this so that we have more space. So, direct design and inverse design, right. So, first we will talk about direct design, then we will come back to this side and talk about inverse design. So, in terms of this task, performance, experience, we talk about direct design and inverse design. So, in terms of that, how do you define that? Well, first let us define task. So, in direct design, what is your task? Your task is very simple: calculate the target properties. Let us write down that, calculate the target properties. As I told you, right, your employer may ask you to first give you target properties, or he may ask you to calculate the target properties. He may give you some paradigm and ask you to calculate, he may give you some paradigm, ask you to calculate the target properties. Okay. Properties or functionality, he may tell you some functionality, like if you are talking about a material for implant in the human body, that must have particular functionality, it should not react with human body, it should not damage our cells, all kinds of things. So, that is what is called target properties are that. Like if you want to design a material for let us say for a bridge on this river or on the ocean. On the bridge you do not need to talk too much about corrosion, but in the oceans you need to very careful about the corrosion property. Like if you want to have a ceiling like in Bombay's, so the important aspect is the corrosion properties, right. Target properties should be material should have much higher corrosion properties. But if you are talking about a bridge on the Ganges, which is far away from the oceans, the corrosion is much less, right. So, therefore, that is what is I am talking about target properties. Other than corrosion, you can have properties like strength, ductility, elastic modulus, many other things. So, first you calculate the target properties of functionalities, okay, and these are then investigated for a particular performance. Okay. So, we have to define the performance measure. Performance measure is what? So, when you talk about target properties, we considered all material domain, all the material available. We never considered anything less or anything less than that. All materials available in the world are considered, and then based on the target properties a performance measure is done. That means which of this material out of the whole material will satisfy the target properties, that is what is a performance measure. So, and training is nothing but experience, right. Training is nothing but experience. Training is what? Training is basically a database, nothing but a database. We will talk about database everything a little later. Database of materials for given set of properties. Obviously, why the hell I will talk about all properties, all physical, mechanical, chemical properties. I should focus on target properties, and therefore, I should have a database of materials for the given set of properties. So, that is what is your training. That database has then material one side, other side you have the properties. So, that is what is the experience for the machine learning, and then once it learns from the experience by training, it basically does the performance, basically develop a model, and based on the model it gives you chemistry of the new material with this target set of properties. That is what is direct design. Remember this. This is normally all of us we do in our life, direct design approach. Whenever you are talking about if you want to go some space, some place to visit, so this is what is we do. First we think about that place, what kind of atmospheric temperature is there, what kind of roads are available. Based on that we select our dress, select our vehicle, select our journey routes, everything. That is what is your target set of properties. So, then your performance, that means how quickly you can reach there, is basically depends on how well trained you are in terms of diving in these roads, how in terms of withstanding the atmosphere through which you are going through. So, that is what is a direct design. So, what is the inverse design then? Well, inverse design starts with task, obviously. So, this is it's search only appropriate set of materials, it does not search all the materials, appropriate only search of appropriate set of materials with defined target properties. Right, that is what it does. So, with some defined target properties, it basically search for appropriate state of appropriate set of materials. That is what is the task for inverse design, correct. And P and E, they remain same as in direct design. So, basically difference between direct and inverse is in terms of search pool. In inverse design you are searching only appropriate set of materials, but in case of direct design you search all materials, you do not be very selective about that. That is what it is called. This is the main difference between these two design principles, and both of them actually used actually in ML, studying ML. So, this is something which all of you should remember very easily. Now comes a very important aspect. Once you know the experience, once you know the design aspects, and once you have some idea about what is what, let us talk about what is actually experience. Okay. This experience is very important in machine learning. Without experience, no machine learning algorithm can do anything. Remember this. Experience is the very important aspects. So, let us talk about little bit about experience and what is experience and all this stuff. So, experience is what? Experience usually exists in the form of data. I already told you, right? Data actually what is providing the experience to the computer. For us human, experience is what? We do something, we do some work, do some exercise, we get some experience out of it. But for computer, experience is nothing, it is basically data. This exists in forms of the data. So, now you have to know what is data, how data are used, and by the way, ML also now can be redefined or rather defined. This is nothing but strategies with given experience, short form actually, if you want to say that above definition is very very broad. This is strategies with given experience to improve performance. That is exactly same as what I told you in this definition also. Okay, so given experience is coming from given data and you have to improve performance. Obviously, this will be for a particular certain task. One experience in certain task cannot be used in some other tasks, right? Task has to be very clearly defined. What is data then? Okay, let us talk about that. Data. Data is set of records. Set of, yes, suppose you do an experiment. Let's take you do an experiment. Let's take a crucible. You took aluminum. Okay. Now you first you put the aluminum with the crucible inside the furnace, melt it down. Then you put a thermocouple connected with a temperature device, and then you list down temperature as a function of time, temperature, correct, as this aluminum is liquid aluminum is cooling down. This is what is used to plot temperature versus time or cooling curve, right? Cooling curve, right? So that's basically set of records. You have different values at different times, temperatures are recorded. That is what is set of records. So data is nothing but that. Data is basically nothing but that, correct? Each record, each record is defined as instances, right? This record is one instant, this record is another instant, like that. So therefore each record is one instant. Now you have to understand that for each instant, or let us say for each record even, there will be certain features or attributes, right? Like this record, this instant has temperature as one attribute, time as another attribute, right? You can have many actually, why not? So you can also measure along with for a particular time, temperature, electrical conductivity, thermal conductivity, right? So you can have 4 different attributes for a particular time. This is, let us say, electrical conductivity, sigma, thermal conductivity, kappa. So that is it. So for each time interval you are measuring 3 attributes. So that is what is the data is. Now what happened? Because of that, for each time you have 3 data, so you have 5 times, then you have 15 data sets, right? That is what is called a data set. So therefore these attributes are what? Attributes are characteristics. They are characteristics. Okay. Performance, let us better write characteristics. That is what is your attribute is. Okay. Please remember this. This is the main definition of attributes is characteristics, and the whole space is called sample space. This space in which the data exists is called a sample space. This is something which is the input to the machine learning, right? Data. So that is a sample space. Now many times the process of obtaining this machine learning model may require you to pre-process the data. Data may not be in a proper format, data may not be in a proper order. So in that case you have to pre-process the data, and this is very commonly used in machine learning. Pre-processing of data is used, and this is achieved by what? Which is achieved by various kinds of algorithms available. We talk about that. So pre-processing of data, is very common. Commonly utilized. So that is very important. Now how does the computer will learn? What are the different ways and means of learning, right? What are the many various ways and means of learning? Let us get back here. So you understood machine learning uses data, and obviously it produces a program to perform a task. This is what is showing here. In standard approach, you write handwritten things, right? Handwritten things, and let us say you want accuracy of about 0.5. If the accuracy is this, then you stand. Accuracy is more than 0.5, you sit, right? Otherwise, you can use equation. You can use equation in terms of various accuracies, beta 1 x accuracy plus beta 2 y accuracy plus beta 3 z accuracy. That is your total activity, right? But in machine learning, you basically do not do that. You feed all your data in the computer. You feed all your data in the computer, correct? And these are actually data are used as I told you, data are nothing but experience, and experience is what is going to provide you more models. Am I clear? So, let us stop it here. I have given you a brief glimpse actually of what is machine learning. In the next lecture, we will talk mostly on this, and then we will carry forward different kinds of models used, statistical model used for understanding the machine learning. Thank you.